Good afternoon, everyone. Thank you very much for coming for our presentation. My name is Luis Caldera. I'm the chief architect on a small fintech company called Orwell. So I'll take the joke out of the way first thing. So we didn't use Kafka because it was already used. So we chose Orwell. And the idea behind Orwell is to provide banking platform support for the financial services. We cover multiple countries, and we're here to share a bit of the things and the work and the investigations we've done in the last year. So, why the name? We're all kind of a bit fond of Viking, so the development team voted, and we decided to pick up a Viking name. All the files and all the code has got Viking titles all over. So it's just developers. So people voted, and that's what we end up using. We do like elephants. We think they're great, but we just like Vikings more. So that's the reason for the name. And it's something out of the ordinary for banks. Banks are, everything has to be 3 letters, all very serious. So what does Orwell do? Orwell focus on banking and in different areas of banking. One of the elements that is very important to us, and one of the main concepts we try to bring forward, is the white labeling of banks. So you want to start a new initiative in a different country, you want to put your brand on a country where you have no presence, we would provide you with the platforms, the licensing, everything that is necessary to start up a bank, literally, from nothing, on a different country. We provide compliance as a service. So if for your GDPR needs, for PSD2, for other legislations, we provide all the support within the platform. And we provide payments, integration with local payments infrastructures as part of the system. You can run the system locally, you can run the system on the cloud. We prefer that people run on the cloud. And it's a very easy introduction to new markets if you use it on the cloud. So one of the things that we looked at is that banks have got very complex estates. Banks have been around for a long time. They have very complex systems. Banks have infrastructures that could have more than 2,000 systems easily. Tier 1 banks especially. They become very complex and everything. And I'm sure it's the experience of all of us here. People who work in financial sector, they have to cope with lots of applications, and we sometimes even struggle to introduce new technologies because it's the whole ecosystem is very complex. It's very these very large estates are very hard to manage and to migrate. So usually what you have is generations of technology from the 60s, from the 70s, from the 80s, and a lot of the banks have their own data lakes, and they've got those things, but all these technologies have to coexist together, and it makes these estates very complex. And sometimes the complexity of these entities, the financial entities, is not just technology, is product-wise, they're very complex. So in the place that I worked in the past, we used to have more than 40,000 products. So the management of the products that have been closed books, it makes it very, very complex to evolve in terms of technology, even evolve in terms of business. So these are the kind of elements that we looked at while we were creating a platform. We needed to make something that is simple, easy, and that addresses some of these issues. So the way we look at banks is literally identifying the functions, and we define that the banks really truly are divided in 2 parts. Where one, which is the distribution, which is the regular channels, the digital channels where there's a lot of evolution and revolution going on, and the products, which is kind of a more banking, boring thing that happens all the time. So you got your overdrafts, your loans, your mortgages. These are the parts where banks make their money. The channels are the distribution part, how to reach the end customers. And so for us, this is very important. This separation is very important because this allows us to then start testing different ideas and different concepts. So how can we address the scenarios that I've described? Very complex business structures, very complex infrastructure structures, technology, and move the technology to a better position. So what we had to build is something that Of course, microservices. Everybody talks about it, everybody uses the concept, but there are pitfalls. So while we investigated how we would approach this, we looked at microservices, but we had to avoid the pitfall of creating more silos. Don't build things application driven. That was the learning that we had. Performance. We have to look at a banking system not like it's a bank, but like if it's a utility. Low profit, low margins of profit, every penny counts. So performance becomes a very important element. If I can do more with less, gives me more benefit and allows me to end up with a better cost-to-income ratio. And those cost-to-income ratios are very important for banks. Very efficient banks, they have got 50 to 60% ratios. If you lower 2 or 3% of that ratio, it's millions a bank can provide the benefits to customers into their own shareholders. So our approach is to look at the infrastructure that provides all that support. Because in today's date, a bank, it's an IT company. It provides IT services to customers with banking functionality. The features, we can't provide a new banking platform or a finance platform that does not provide the same features that customers have got today, because that would be a loss. Effectively, no one will adopt something that provides less capability than the existing platforms. And usually the biggest problem of all, data quality. So when we look at doing migrations of information, I'm sure everybody who's worked on the migration of data to a lake, data quality is always the biggest issue. Data is not standardized, the data is completely different. You got multiple sources, you have to merge them. Sometimes we load all the data into the lake and then try to manipulate it, operate on it. It's very, very complex. It's one of the elements that introduces complexity. So we spent some time figuring all these things out, consulting, we had discussions with Hortonworks from the beginning, ideas, we exchanged ideas with them and everything. So we reached kind of a set of interim steps of the evolution of thought. So we need technologies that allows us to replace mainframes, that replace capacity. Okay, so we can address that. We need the same reliability of the existing systems. And that, for a bank, for the regulator, is very important. The regulator will ask, well, how much time, if something happens, how much time are you going to be down? Usually the answer to the regulator is, oh, it's going to be a few minutes or an hour, or the regulator does not want to hear, oh, we might be down for 2 days because the technology is different from existing. So that's assuring messages have to be given to the regulators, and it's one of the things that we went through with them. So we reached a very interesting technology stack. We've identified all the technologies we liked, so we went to the zoo and just pick up all the interesting technologies, all the lovely technologies, and said, I will use this technology for this specific banking function. And that's how we allocated. We identified financial processes and said, I will meet these targets with these technologies. And by the way, some of the existing financial institutions, they already have agreements with Amazon, Google, Microsoft. We can't just tell them, no, we don't like Azure, we like Microsoft, or we like Google more. We have to respect that they have present agreements, and that's how it operates. So we need to provide something that allows them to do all to evolve, but still respect their existing contracts. So what did we do? We had all that zoo. It's very complex to go and get an engineer to work on rocks, an engineer to work on Hive, an engineer to go. This is specialized knowledge. It's very hard. So what we decided is to group the functionality and identify where can we get the most support, the best support possible. And because we've been involved with Hortonworks, especially I've been involved with Hortonworks for more since 2014, the idea was, okay, so we need final stores, we need all these technologies. Let's look at the different capabilities that Hortonworks provides us. So a lot of the analytical functionality we can get out of HTTP. Some of you, I'm sure they've already used it. Others not probably are starting. And we looked at the operational side, which is HDF. And for us, the main thing is the HDF side. So effectively, what we've done is identify which elements of HDF we're interested in and how they benefit of us a creation of a bank. So we've identified that for example, Kafka and Storm, they allows us to do streaming, perfect. Allows us to look at information and manage information. Usually Kafka and Storm is used for after the event, to produce analytics. Our focus here was it's part of the core bank. So any operations are running there in real time as if it was a core banking system, an operational system, not an analytics view. How do we prototype everything very quickly? So we used SAM, so the Streaming Analytics Manager, to prototype, create what we call steel threads, meaning end-to-end flows, very simplified, that allows us to accelerate development. And then even making use of Embody to distribute our own components themselves, as well as Apache Ranger. And Apache Ranger is very important for the regulator, on the conversations to the regulator. The regulator always says, data at rest needs to be encrypted, data inflow needs to be encrypted, you can't do certain things. And these are conditions that the regulators will put to have a whole bank in the cloud. So we went through this with the FCA in the UK, and we're directly working with the different authorities on the different countries where we operate. So what did we do? We thought HDF is part of our core banking system. This allowed us to focus on the accounting mechanisms and the resilience of the systems. So what we've created is, we use called DDD, domain-driven design, kind of architect's words. But what it means is, we did a separation of the different functions within the design, and what we did was, we've identified that accounting is a mathematical operation. So we've created dedicated engines to operate on accounting, and we use other elements to gather data and process data. The design overall is not that different of Apache Metron, which is quite interesting. So it uses the same concepts of data preparation and then data processing at high speed and streaming. So another important factor to allow resilience is that we found out is that we have to track every banking process. We need to be able to tell a customer, I've got all this information about you, I've got all the details necessary, and I need to prove to the regulator that everything I've done is correct. So what we've done is effectively reuse the same technology that executes our processes in real time to monitor the processes being executed. So nothing on our platform goes unmonitored. And this is just by design. We use the Kafka pub submodel and Storm and Kafka streams to achieve this goal. So in here we have a full running operational bank running in real time in Kafka Storm, Kafka streams, with all the security embedded from Ranger. We've got full data traceability from end to end. And when we don't need the data, when the data is end of life in terms of stream, we load it to the lake with full metadata associated, labeled, everything necessary and ready for analytics consumption. So what I think we are a very good example of the value of open source. What we've done is to optimize the performance of our components, we've reused the code, the Kafka code, and the way Kafka talks between nodes to optimize our communications. So effectively, our nodes use Kafka as our ledger itself. And every time one node fails, the next follower will pick it up. Our recovery time between failures is around 400 milliseconds. So we've done the test for the FCA. They asked us, show us that you can do it. And in 400 milliseconds, on failure, our system just immediately recovers from failures. We got a completely distributed ledger and a completely distributed accounting system. So It's literally I can have many nodes all executing on bank accounts in parallel. So one of our customers asked, show us in live, real time, we're here with you, show us that it works. So we did a test with them. We run on 2 what we call processor nodes, and we did 12,000 payments per second on that execution. So in front of the customer to produce the end, we can do more than 3,000 transactions on one single account. So this allows us to just go beyond the limits of a database. So this effectively runs as fast as possible with the maximum resilience. We never lose data, and we always recover from failures automatically. And this is, a lot of this code is code that is part of the open source community. We reused the code, we forked parts of the project, and we've extended it. Another of the things we've done is effectively we reuse Embody to deploy our own components. Embody already does this perfectly for Hortonworks. Why doesn't do it for us? So our components are being distributed through the cluster using Embody, which makes it very easy. One console to control. So when we think about the cost-income ratios, if you have a support team of 100 people, will have a price. With one control console, you could reduce that, for example, to 10 people. I'm not trying to get people out of the way or people lose jobs. It's just that people can then be focused on other things that are more important. So this effectively allows one console to control all the operations. So this is the design that was done for faster payments in UK. So we got through our certification to connect to the faster payments infrastructure. It's the first Kafka-oriented system connected to the faster payments infrastructure in the UK. So what it shows is that we use the system in a way that provides all the functionality that any bank does and at a fraction of the cost. So our the cluster that runs this effectively costs £1,200 a month. It doesn't cost millions to operate. And this has got capacity. We tested with the industry. It's got capacity to generate 450 payments per second. But just to have perspective, the UK faster payments capacity, overall payments capacity across the whole country in real time is 717 payments per second. This is the overall. We did it on one node, execution node. So it's just to see, so capacity is not an issue. We've removed the capacity. We've now are able to reduce the cost because we can operate very cheaply and very safely. And effectively, the same infrastructure is used to monitor. So we track the payments at the second level. Payments coming in, payments coming out. I can look at it. I can explode the information on the payment. We always store every piece of data on the platform. Another, oh, interesting. A slide with a wrong arrow. So what we've done about this is what we imagine is that a bank doesn't have an instance. It will have 2 instances in 2 different countries or 3 instances in 3 different countries. So what we've developed is a network based on kind of a technology derived from the torrent protocol to, in a peer-to-peer fashion, distribute enough information to do dynamic routing of payments across multiple nodes. Our CEO is always proud to go into a crowd and say, all payments in our network are free. Because through the technology, it's so cheap, charging for the payment becomes ridiculous. It's just the numbers are so small. So we can route information across multiple instances. So we can have an instance in Germany, one in the UK, one in the US, and you can make a payment to the US instantaneously. And the person in the US, a second later, depending on the network latency and all these things, it will get the payment. So it's pretty unique. We can dynamically attach new nodes. So any multiple entities wanting to participate, they connect into the network, the nodes acknowledge themselves, and automatically you can start making payments within that network for free. So we do make use of CI/CD. So we do use Kubernetes, we do use all the elements. All our infrastructure is code. So if I want to build a cluster, we press a button, we build the infrastructure with all the necessary elements. So HDP, HDF, they get deployed with blueprints and automatically get deployed. And then Embody distributes our own components. So we can run on any cloud, and we got a certain level of cloud being cloud agnostic. So if a customer wants to run on his data center, we're okay. If the customer wants to run on a cloud, which we prefer, we can run on any of them without detriment. So we do make use of some of the cloud features. Others, the Hortonworks functionality allows us to do almost everything. So one thing is very important is this is not just about optimization, it's giving value to the banks and customers too. So what we've done is we've created a system similar to what General Electric does to their airplanes engines. So every airplane engine from General Electric transmits telemetry to their main office to monitor all the activities, even if they are in the air, pushing information. Same thing happens with the Airbus airplanes. So every mobile, everything, when the customer provides the consent, we'll record the clicks, we'll record how much time the customer moves through screens. We store all that information, and then we can even identify if the person using the phone is the right person. Because after 15 movements, we can clearly identify if it's the regular user or the person just lent his phone to his kids and his kids are making some payments. So that's the kind of benefit, and we provide a full SDK and provide an app that allows us to take advantages to our own customers. And of course, it's the ability to how fast can we introduce new processes, new products. So I mentioned the issue about products. It's all about agility. So we provide all the functionality in Zeppelin. So internal operations, reporting, even apps. We even build apps in Zeppelin for fast prototyping. So for us, it's speed to market. And all the monitoring is standardized. In this case, we use Prometheus as our main data aggregation, time series aggregation for execution. Our network is designed to provide one central point of monitoring. So if a customer says, I would like you guys to be my first line of monitoring, we can monitor remotely all the activities through our network. And of course, we provide APIs for the third-party developers to build upon. So they can use our APIs. Our APIs are streaming APIs. In our platform, there's no concept of a continuous TCP connection. We published it into Kafka. Everything is published and subscribed, command-driven and event-driven system. So we've integrated already with multiple entities. We've passed accreditation for BACS in the UK, faster payments. We're effectively working with the Bank of England now to go to CHAPS and so on. So these are the concepts that we're trying to make. So it's optimize. Reduce cost of operations, reduce cost of how finance works. And this is something that has been done in other industries. Finance is just one that needs to move through these cycles of optimization. So Hortonworks was essential for us to move forward. It's how fast can we develop. So we concentrated on the banking functions. Hortonworks provided some of the other functions. Our system has no concept of batch. So everything runs in real time. We process all the content in real time. It's real-time monitored. And we've removed the limitations, the existing limitations that exist on databases, updating, having records, and so on. For us, everything is about efficiency. If a process is not efficient, costs money, it's expensive for us and for our customers. And we provide compliance, so sanctions, fraud, anti-money laundering functions, they're all built in within the platform. And they all take advantage of profiling the users for real-time monitoring, profiling the users in terms of how they behave so that we can have safe operations. Thank you. Any questions? Mm-hmm. 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 Yes. So the platform is designed to be extended. We provide some bases. If the customer wants something different, we'll customize it to the customer, and we keep track of all the versions of the code. And we provide repositories to upgrade, but we have some default modules. Yes. Any more questions? Mhm. Mhm. So in our accounting system, it's zero RPO, and it's designed specifically with that in mind. So it uses the replication for functionality similar to Kafka to replicate in real time all the information, and it has multiple recovery points. So if a node fails, we recover from the ledger or recover from the execution logs automatically. So it's designed to have no failures. And when we run in terms of AWS, we immediately run, or AWS or others, we run on multiple availability zones automatically. Well, if there's no more questions, thank you very much for your presence. And if you got any questions that you have afterwards, just send us an email or just send me a message on LinkedIn. And I'm happy to go through any ideas, any concepts. Everything you've seen here, I'm sure Hortonworks will publish the presentation, but from time to time, I publish all the designs of the platform online in LinkedIn. So thank you very much.